right, take your notebooks out.
That's my hair.
For today's date, 10/7. You're on 2-2, properties of operations.
What's today's date? Oh, October 7th.
And then you'll put your pencils down. We'll go through the entire lesson slide by slide, and then at the end of the class, we'll give you time to copy down the notes. Ready?
No.
Ivan?
For the is it going to be like a series or just one class?
You're hoping to do every lesson, record every lesson. Yeah.
Woo! That's gonna be sick. I'm gonna be famous.
All right, I want you to look at this equation. 8 plus 10 equals 18. And I want you to use the same operation and the same add-ins, meaning the numbers that you are adding, and get the same result. How else can you do it? Lindsay?
10 plus 8 equals 18.
10 plus 8 equals 18. What did Lindsay do? Alba?
She switched the numbers around.
She switched the numbers around. Did we end up with the same result?
Yeah.
Yes. Okay. Now, this property is called the commutative property of addition. Now, according to this property, can someone state this property in your own words based on what we just talked about? Yes?
Well, probably the switching of two numbers to get the same result.
Okay. So the property states that the order in which the numbers are added does not affect the sum of the numbers. Whether you do 10 plus 8 or 8 plus 10, you get the same final result. Now, algebraically, this is how you write it. A plus B equals B plus A. So I can say 8 plus 10 is the same as 10 plus 8. Now here's a way to remember what commutative means. What does commute mean? When I say I commute to work by train, what are you doing? Yeah, go ahead.
To travel.
To travel, to move from one place to another. So when you look at commutative property, what I need you to see is how the numbers are traveling. They're moving around. The order is changed. 10 has taken the place of 8 and 8 has taken the place of 10. You're not introducing anything new to the equation. You are simply changing the order in which the numbers are added. Cameron.
Oh wait, never mind. I was gonna say if you could, it would have to involve subtraction. Never mind.
Okay, all right. Ivan.
Let's say if you were adding something new to it, and let's say it was like 32 minus 18 or something like that. What would that be called? Like, and that would say like equals 10 plus 8.
It has to be the same operation.
Okay.
And it has to be the same
Two
numbers.
Okay.
Okay? And do you think it would work for subtraction?
No.
Is 10 minus 8 the same as 8 minus 10? No. So this property only works for addition and one other operation. Kate? Multiplication. Which is the next page. So, based on what we just learned in the previous slide, can someone state this property the way it should be stated? Cameron.
Do you mean like the numbers or the definition?
The definition.
Oh, like if you switch the numbers in multiplication, it won't change the.
I want you to use one keyword. Molly?
If you switch the factors in a multiplication
switching is close, but not what I'm looking for.
If you commute,
No, Kate again.
I was like switching, like changing, not like
Changing the what?
Number.
Not like
The numbers, you're not changing the numbers.
Where they are.
Okay, which has another word, what's the synonym?
That's the key word. All right? The order in which the numbers are added. Do you see that here?
Yep.
There we go, order. So the commutative property of multiplication states, Caitlin, that
that
the order in which
the digits or the numbers.
the numbers or factors are multiplied does not affect the product of the numbers. Okay? So here are some examples. 11 times 9 is 99. 9 times 11 is also 99. That's to say 11 times 9 is the same as 9 times 11. How do I write that algebraically?
A times B
Very good.
equals B times A.
Excellent. A times B equals B times A. Good?
Yep.
All right, two properties, commutative property of addition, commutative property of multiplication. Do you think there are more properties?
Yeah.
Okay, there are many properties. When you come to 7th grade, we'll do this in depth a little bit more. Actually, in a month's time, you will see a lot of poster boards come up on both the 4th and the 6th floors. The 7th graders are working on a properties poster where they take 10 properties and they have to state the property. They have to use props to illustrate the property. So you will see candies, you'll see an orange starburst plus a green starburst equals a green starburst plus an orange starburst. So you will see things like that.
Can I ask you a question, Father?
Yes, Ms. Fallon.
For this one here, is 99 equals 11 times 9?
Is 99 equals 11 times 9?
Is that commutative property of multiplication, if we wrote it that way?
Phineas, what do you think? This is what Ms. Fallon is saying. He's saying, is that commutative property?
Yes.
Raise your hand if you think it is. Okay. A third of the class.
I mean, I changed the order, right? That's the thing, changing the order, commutative property.
I think if it was 99 equals 9 times 11, it would still be 99.
Yeah, because you're.
But is this commutative property?
No.
No.
No, because
Why? Mika?
you have to change the factors for it to be.
Oh yeah, you're teaching.
Okay.
Yeah.
Also, remember when Ms. Fallon did the lesson on equations, I can say 3 plus 5 equals 8, or I can say 8 equals 3 plus 5. Because in equation, what it means is the left side equals the right side. You can switch them, but that's not commutative property. Commutative property, in order for it to happen, has to happen on one side of the equation. Do you understand? So like here, you have 11 times 9, and on the same side, I change the order and write it as 9 times 11. Okay? Right, your body is straight? Okay, thank you. Right, now I have 3 numbers. I want you to add these numbers, and I want you to tell me your thought process. What numbers are you adding first? Troy,
I'm adding 7 plus 10 first.
you're adding 7 plus 10 first for whatever reason, because you think that would be easier to add.
Because I added the 2 biggest numbers first.
Oh, you add the 2 biggest numbers. So we all have our own strategies, right? When we're adding numbers.
Yeah. And
Okay.
then after that, the 3 is equal that equals 20.
Okay, that everything adds up to 20. So 7 plus 10 is 17, and you add 3 to 17 and you get 20. Lena?
I would do 3 plus 7 first because then it brings you to 2 tens and it's
Okay.
easier and more compatible.
So you see that they are compatible numbers and they add up to a 10. You know these addition facts and multiplication facts, right? 3 plus 7, 4 plus 6, things like that. So 3 plus 7 is 10 and 10 plus 10 is 20. So the option 1 is Lena's option. Add the 3 and the 7 first and then add 10. The second is, oops.
What's happening?
The second is Troy's way of doing it. And okay, now before we get to Troy's, how do I show that I'm adding 3 and the 7 first? What am I introducing here? I'm using a grouping symbol called parentheses. So when I introduce that grouping symbol, it tells me right away that I need to add the 3 and the 7 first. Those two are grouped together, right? And then you can add the 10. And if I'm using Troy's method, where would I introduce the parentheses? Then
Around the 7 and the
around the 7 and the 10, and that would tell you add those two first and get 17 and then add the 3 to get a 20. All right? Can someone state this is called the associative property of addition. Can you tell me, you use your own words and tell me what this property might state? Mika?
Two expressions can equal the same thing as long as it has the same atoms or factors.
Okay, close, very close. Yeah, Phineas?
It doesn't matter which atoms you add first. You'll always get the same thing.
All right, I'm looking for a key word. What is the key word with commutative? Order. And the key word here is, you want to guess?
Associate.
There you go.
Hey!
All right? States that the way numbers are grouped does not affect the sum. And this is how I would state the property. Ivana, are you with me? A plus B grouped together, then C added to it, is the same as B and C grouped together, and then A added to that. Cool? All right, one way to remember it, what does associate mean? If you're associating with someone, what are you doing?
You're like if you're associated with someone in a crime, that means that you were like with them, kind of.
Yeah, you're partnering with them, right? Okay. Now, even if you're associating with another person, doesn't have to be in the context of crime, but just generally speaking, you just hang out with someone. What are you doing? You are associating with that person. You can be working with that person, just hanging out with that person. You're friends with that person. So the moment you hear the word associate, what needs to come to your mind? Grouping, right? You're part of the same group.
A lot of businesses will call themselves Fallon and Associates.
Mm.
You know, like lawyers or accountants or things like that. Like, you know, Hazelton and Roger Regan and Associates, and then it's U2 plus
Others,
people that
okay,
work with you.
okay.
They're your-
They're all part of the same group. All right? Okay, so if this is the associative property of addition, what is the next property?
Oh, can I ask one?
Yes,
one
Ms.
question
Fallon.
before we do that?
Sure, sure.
Can you see the blue and purple 3 plus 10 grouped together? 3 plus 7 plus 10, right? Where Father's pointing there. And then in the box you've got A plus B grouped together plus C. Between that line and the A plus B plus C part down there, what do you notice about those two things? What didn't happen in those two things? What? Yeah.
Like the letters never really changed in one.
What about the letters?
The letters stayed, like they didn't. The parentheses didn't have to move before the 3.
Right.
They stayed
In the
in
same.
the same spot and the same.
What's that word that we liked from the other property?
The same order?
Yeah. Did we change the order? Did we commute anything? No. So in associated property, is anything moving around?
No.
The only thing that's different is
The parentheses.
parentheses, what you put
Correct.
together.
Okay? Right, so 4 properties down, 2 more to go. The next one is identity property of addition. I'm going to give you a little hint. Identity means same. So essentially what I want to happen is I want to start with a number, do something to that number, and end up with the same number. The operation is addition. So what should I add to a number to get the same number? Molly? 0. So this property would state that the sum of a number and 0 is the number itself. And how do I write this, Tyler, in algebraic form? Symbolically?
Sum